Here is a point on a circle. Coordinates -5 and 12, and theta has already swept past 90 degrees. Sine of theta, cosine of theta, cosec of theta. No calculator, no acute triangle in sight. Where do we start? Park these in the corner. By the end of the lesson, you will read them straight off the picture. Drop a line from P straight down to the x-axis, a right triangle. Legs x and y, longest side the radius r, 13. Sine of theta is y over r. Cosine is x over r. Watch them run live. Past 180, the perpendicular still drops. X and y just carry signs. Past 270, same story. Wind back to a small angle, the form for triangle again. The rule this picture earned. Sine y over r, cosine x over r, tangent y over x. 3 more ratios, and they are just these fractions flipped upside down. Flip sine and you get cosecant, r over y. Flip cosine for secant, r over x. And flip tangent for cotangent, x over y. One warning, cosec sounds like cos, but it belongs to sine. Cosec inverts sine, sec inverts cosine. All 3 go on the shelf. Cosec r over y, sec r over x, cot x over y. Now watch only the signs of x and y. Green positive, orange negative. Quadrant 2, y positive, x negative. Sine is positive here too. Quadrant 4, x is positive again. Cosine is positive here too. Quadrant 3, x and y both negative. Tangent is positive here too. Put it together and it spells itself. All sine, tangent, cosine. ASTC. Sines done. Now the size. Start with 30 degrees in orange. The real angle, 150 degrees, lands in the second quadrant. The gap back to the x-axis, 180 minus 150, 30 degrees. That gap is the reference angle. The ratio sizes at 150 match those at 30. AST, C gives the sign. Back to P, with R 13. Sine 12 over 13, cosine minus 5 over 13. Minus theta, the same turn clockwise. P reflects through the x-axis. X stays, y flips to minus 12. So sine flips, minus 12 over 13. Cosine does not even notice, still minus 5 over 13, identical. The exam trap. A negative angle never flips a ratio upside down. Sec of minus theta is just sec theta. Radians are just a different ruler. Half turn pi, full turn 2 pi. So 180 minus theta becomes pi minus theta. And 360 minus theta becomes 2 pi minus theta. Same geometry, new labels. 150 is 5 pi over 6. The gap, pi minus 5 pi over 6, pi over 6. Same gap in radians. Quick guess, does cotangent flip here or stay the same? Take a point at an acute angle beta, coordinates x and y. Mirror it across the vertical. Y stays, x flips sine, landing at pi minus beta. Read cotangent off the picture. X over y becomes minus x over y. Cot of pi minus beta is minus cot beta. So it flips. Here is how you tell every time. Count the 90-degree blocks. 180 minus beta, 1 block, 2 blocks, even. 90 plus beta, 1 block, odd. 270 minus beta, 3 blocks, odd. 360 minus beta, 4 blocks, even. Same count in radians. Pi is 2, 3 pi over 2 is 3. One line to remember it. Odd swaps to its partner, sine and cosine, tan and cot, sec and cosecant. Even stays. The quadrant sets the sign. 2 checks. Cot of pi minus beta, even stays cot, quadrant 2 negative. Sine of 90 plus beta, odd swaps to cos, quadrant 2 positive, plus cos beta. Sine 12/13, cosine minus 5/13, cosec 13/12, your own question answered. Back to the parked question. You own every tool it needs now. Example 1. Example 1 is the parked question. P at minus 5, 12, theta in quadrant 2. Find cos theta, cosec theta, sec of minus theta. Sketch first. P top left, theta swept past 90. Find R. Legs 5 and 12, root 169, 13. Step 2, pin the quadrant. X negative, Y positive, quadrant 2. Part A, straight off the picture. Cosine is x over r, minus 5 over 13. Part B, sine is 12 over 13, so cosec is the flip, 13 over 12. Part C, minus theta reflects P downward, cosine unchanged. So sec of minus theta is 1 over cos theta, minus 13 over 5. Part A minus 5 over 13. Part B, 13 over 12. Part C, minus 13 over 5. Example 2, letters and radians. B at minus h, k radius r, beta between pi over 2 and pi. Find sin beta, cot of pi minus beta, sin of minus beta. Same sketch, letters instead of numbers. R is root h squared plus k squared. The minus sign dies inside the square. Quick guess before you check. Which quadrant does this land in? Step 2, where marks die, 1 minus sign is not quadrant 4. X negative, Y positive, quadrant 2. Part A, sine is y over r, k over root h squared plus k squared. Part B lives in radians, and you already have the tool. Pi minus beta is 2 quarter turns, even so cot does not swap partners. Cot beta is x over y minus h over k. Even keeps cot, the quadrant flips the sign, h over k. Part C, minus beta reflects b, so sine flips sine, minus k over root h squared plus k squared. Reflection, never reciprocal. Part A, k over root h squared plus k squared. Part B, h over k. Part C, minus k over root h squared plus k squared. That point past 90 degrees, no calculator. Find r, read the signed coordinates, and every ratio falls out of the picture. The 5 moves, find r by Pythagoras. Fix the quadrant from both signs, never guess. Reference angle, same unit as the question. Sine from A, S, T, C, and cosec, sec, cot are just the flips.